Hello students, here is an example on indeterminate truss solved by the method of least work. So analyze the truss shown by the method of least work. Cross-sectional area in millimeters square is 600 for outer members, these members here, and 750 for inner members. Modulus of elasticity is 200 gigapascals. So to solve for the reaction, summation of moments about E equals 0. So AY times 13.5 plus 30 times 6 equals 75 times 4.5 plus 50 times 9. So we will get AY equals 45 kilonewtons. Likewise, summation moment about A equals 0, RE times 13.5 equals 50 times 4.5 plus 75 times 9 plus 30 times 6. So R sub E is 80 kilonewtons as shown. Then summation forces X0, AX should be 30 kilonewtons leftward rather, opposite to this 30 kilonewtons. So having found the reactions beginning at A, summation forces Y equals 0, the slope of the sloping member is 3 horizontal, 4 vertical, so 5 hypotenuse. So SAB times 4 over 5 plus 45 equals 0. So SAB is negative 56.25 kilonewtons, and this is the final member force of AB because it is not a function of the redundant. By the way, the truss is indeterminate to the second degree, and I selected SBF and SCE as redundant forces. I represent them respectively by F and Q. So there are two redundant forces, F and Q. Then summation forces X at A. So SAG plus SAB, which is negative 56.25 times 3 over 5 equals 30. So SAG is 63.75 kilonewtons positive, so it is tension, and that's the final member force of AG. We then proceed at B. Summation forces X0 SBC plus F times 3 over 5 equals negative 56.25 times 3 over 5. So SBC is negative 0.6 F minus 33.75. Summation forces Y equals 0, downward positive SBG plus F times 4 over 5 plus negative 56.25 times 4 over 5 equals 0. So SBG is negative 0.8 F plus 45. Then we proceed to joint G, summation forces Y equals 0. SCG times 4 over 5, then plus SBG, which is negative 0.8 F plus 45, then equals 50. So SCG is equal to F plus 6.25. Then summation forces X, SFG plus SCG, which is F plus 6.25, the horizontal component, multiplied by 3 over 5, and equals SAG, which is 63.75. So SFG therefore is negative 0.6 F plus 60. Then we proceed at joint E, summation forces Y equals 0, SDE plus Q times 4 over 5 plus 80 equals 0. So SDE is negative 0.8 Q minus 80. Then summation forces X equals 0, leftward positive SEF plus Q times 3 over 5 equals 0. So SEF is negative 0.6 of Q. Then at joint F, summation forces X equals 0. So SDF times 3 over 5, SDF times 3 over 5 plus SEF, which is negative 0.6 Q, equals F times 3 over 5, horizontal component of F, F times 3 over 5 plus SFG. And SFG is quantity negative 0.6 F plus 60. So simplifying, we can cancel F, negative 0.6 F. So SDF is Q plus 100. So 0.6 Q over 0.6 is Q. Then 60 divided by 0.6 is 100. Then summation forces Y at F, SCF upward plus, or SCF plus SDF, which is quantity Q plus 100 times 4 over 5 for the vertical component, plus F times 4 over 5 equals 75. So SCF is negative 0.8 F minus 0.8 Q minus 5. Then we proceed to joint D, summation forces X equals 0. So 30 equals SCD plus the horizontal component of SDF, which is SDF is Q plus 100 times 3 over 5. So SCD is equal to negative 0.6 Q minus 30. Then we check equilibrium at D by summing up forces Y, downward positive. So SDE, remember, is negative 0.6 Q minus 80 plus SDF, quantity Q plus 100 times 3 over, times 4 over 5. Then we can eliminate Q, we can eliminate the constant, negative 80 plus 80 is 0, so it checks. Then we check the equilibrium at C, summation forces X, SCD, which is negative 0.6 Q minus 30, plus horizontal component of Q, which is Q times 3/5, minus SBC. SBC is, so minus quantity negative 0.6 F minus 33.75 minus the horizontal component of SCG, and SCG is minus quantity F plus 6.25 times 3/5. So we can eliminate the F, 0.6 F minus 0.6 F, then negative 0.6 Q plus 0.6 Q, then the constant negative 30 plus 33.75 minus 6.25 times 3/5, so it's 0. So it's okay. We have checked the equilibrium of the whole truss, and therefore the calculated member forces in terms of F and Q and the other member forces that are already found finally are correct. So we tabulate summation forces by Y, by the way, at C is 0, downward positive. So Q times 4 over 5 plus SCF, which is negative 0.8 F minus 0.8 Q minus 5, then plus vertical component of SCG, which is quantity F plus 6.25 times 4/5, and it is also 0. So tabulating, these are the members. There are 13 members actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But since we already finalized the member forces of AB and AG, so we just tabulate the remaining 11 members. So these are the 11 members: BC, BF, BG, CD, CE, CF, CG, DE, DF, EF, and FG arranged in alphabetical order. So for BC, the force is negative 0.6 F minus 33.75. The partial derivative of S with respect to F is negative 0.6. So since it is not a function of Q, partial of S with respect to Q is 0. The length of BC is 4.5. Then the product of S, partial of S with respect to F times length is 1.62 F plus 91.125. While S, partial of S with respect to Q times L is 0. Then BF is F actually. So derivative of S with respect to F is 1. Partial derivative of S with respect to Q is 0. Length of BF is 7.5, square root of 4.5 square plus 6 square. So 7.5. The product S, partial of S with respect to F times length is 7.5 F, while S, partial of S with respect to Q times L is 0. BG is negative 0.8 F plus 45. Then partial derivative with respect to F, negative 0.F. With respect to Q0, the length is 6. So the product S, partial of S with respect to F times length is 3.84 F minus 216, while S, partial of S with respect to Q times length is 0. CD is negative, CD is negative 0.6 Q minus 30. Partial derivative of S with respect to F0 with respect to Q, negative 0.6. Length is 4.5 for CD meters. So S, partial of S with respect to F times length 0, while S, partial of S with respect to Q times length is 1.62 Q plus 81. Then CE, which is just Q, partial derivative of S with respect to F0 with respect to Q1, length 7.5. So S, partial of S with respect to F times length 0. S, partial of S with respect to Q times length 7.5 Q. Then we have CF, which is negative 0.8 F minus 0.8 Q minus 5. Partial derivative of S with respect to F, negative 0.8. With respect to Q, negative 0.8. The length is 6. So S, partial of S with respect to F times length is 3.84 F plus 3.84 Q plus 24. And that is also for S, partial of S with respect to Q times length, 3.84 F plus 3.84 Q plus 24. CG is F plus 6.25. Partial of S with respect to F1 with respect to Q0, length 7.5. So S, partial of S with respect to F times length is equal to 7.5 F plus 46.875, while S, partial of S with respect to Q times length is 0. Then DE, negative 0.8 Q minus 80, partial derivative with respect to F of S is 0, with respect to Q, negative 0.8. Length is 6, so S, partial of S with respect to F times length 0. S, partial of S with respect to Q times length is 3.84 Q plus 384. DF, SDF is Q plus 100. Partial derivative of S with respect to F0 with respect to Q1, length 7.5. So S, partial of S with respect to F times length 0, while S, partial of S with respect to Q times length is 7.5 Q plus 750. Then EF is SEF, negative 0.6 Q. Partial derivative of S with respect to F0 with respect to Q, negative 0.6. Length 4.5, so S, partial of S with respect to F times length 0, while S, partial of S with respect to Q times length is 1.62 Q. Then finally, for FG, SFG is equal to negative 0.6 F plus 60. Partial derivative of S with respect to F, negative 0.6 with respect to Q0. Length 4.5, so S, partial of S with respect to F times length 1.62f minus 162 s partial of s with respect to q times length is 0. So we now set up partial of u with respect to f, which is the relative displacement of bf, which is 0, and this is summation of s partial of s with respect to f times length over ae equals 0. So we add this part and equate it to 0, but we cannot simply add. We have to indicate because the area of the outer members is different from the cross-sectional area of the inner members. So BC is an outer member, BF inner, BG inner, CD outer, CE inner, CF inner, CG inner, and DE outer, DF inner, EF outer, FG outer. So we add the inner members first. So we have 7.5F plus 3.84F plus 3.84F plus 7.5F, then no more. That would be 22.65F divided by area, which is for inner members 750, then E. Supposedly we multiply this by 1000 squares, but since we multiply also the rest by 1000 square, so we will not multiply 1000 square anymore. So just divide area times E. And E can be cancelled after we cross multiply because we equate it to 0. So for Q, for inner members, this is the only inner member with Q, 3.84Q. So that's why we have 3.84Q over 750E. For the constant inner, we have negative 216 plus 24, then plus 46.875, no more. So negative 216 plus 24 plus 46.875 is negative 145.125 divided by area of inner member 750 divided by E. So that's for the inner. For the outer, in this column, we have 1.62F and 1.62F. So 1.62F plus 1.62F is 3.24F divided by area of outer members 600. So 600E. For the constant, for the outer members, we have positive 91.125 and negative 162. So 91.125 minus 162 is negative 70.875. Then divided by area 600E equals 0. So we cancel E and simplify 22.68 F over 750 plus 3.24 F over 600. That's 891 over 25,000 F. Then for Q, 3.84 Q over 750. That reduces to 16 over 3125. Then this negative constants to the right would be positive 145.125 over 750 plus 70.875 over 600. That's 2,493 over 8,000. So call this equation 1. Then partial of U with respect to Q equals 0, and this is summation of S, partial of S with respect to Q length over AE. So we add these columns here correspondingly with same area, then equate it to 0. So we begin with the inner members first. So we have 3.84Q over 3.84F rather over area of inner 750 over E. Then for Q inner, so 0, 0, we have 7.5 Q here, then plus 3.85 Q inner, then plus 7.5 Q. That would be 18.84 Q divided by area of inner member 750 E. Then for the constants for inner members, inner we have 24, and 750. So 24 plus 750 is 774 divided by area of inner member 750 divided by E. So that's for the inner. For the outer members, you have 1.62 Q plus 3.84 Q plus 1.62 Q. So 1.62 Q plus 3.84 Q plus 1.62 Q, that would be 7.08 Q divided by area of outer member, which is 600 divided by E. And for the constants for outer members, 0, we have 81 and 384. 81 and 384, so that would be 465. Then divided by area of outer members 600, then divide by E equals 0. So combining like terms, 3.84 F over 750, that reduces to 16 over 3125 F. Then for Q, 18.84 plus 7, 18.84 over 750 plus 7.08 over 600, that's 923 over 25,000 Q. Then for the constants, transpose to the right, so negative 774 over 750 minus 465 over 600, cancel out E, is negative 1807 over 1000. So we have equation 1, equation 2. Solving these two equations simultaneously, we get SBF, which is F, 16.096 kilonewtons, and SCE, which is Q, equals negative 51.176 kilonewtons. Then, having found this, we can now finalize the member forces of these remaining 11 members. For BC, negative 0.6 of F, and F is 16.096 minus 33.75, so that would be negative 43.408 kilonewtons. For member BF, which is just F, so 16.096 kilonewtons. For member BG, negative 0.8 of F, negative 0.8 of 16.096 plus 45, that's 32.123 kilonewtons, so positive, it is tension. For member CD, negative 0.6 of negative 51.176, then minus 30. So it is 0.7056 kilonewtons positive, so it is tension. CE is Q, and Q is negative 51.176 kilonewtons. So that's the final member force of CE. CF is negative 0.8 of 16.096 minus 0.8 of negative 51.176 minus 5. So SCF is 23.064 kilonewtons. CG is F plus 6.25. So 16.096 plus 6.25 is 22.346 kilonewtons. DE is negative 0.8 of Q, negative 0.8 of negative 51.176 minus 80, that's negative 39.059 kilonewtons. DF is Q plus 100, negative 51.176 plus 100 is 48.824 kilonewtons. EF is negative 0.6 of Q, negative 0.6 of negative 51.176 is positive 30.706 kilonewtons. Then finally, for FG, negative 0.6 of 16.096 plus 60, so 50.342 kilonewtons. So that's it for this problem. If you want more examples, especially for a truss with only 1 degree of indeterminacy, you can visit my YouTube channel. There are other examples there and for you to master and practice. So that's it, and I will no longer present this in the face-to-face lecture because we ran out of time, and anyway the explanation would still be the same. So if you want to anticipate the solution, it is your responsibility to study in advance. Anyway, there are so many problems and the concepts are presented in my YouTube channel. And for problems, there are numerous problems there. So that should be your attitude. You have to study in advance if you want to pass or understand this course.